Friends, architects, engineers, consultant engineers, HVAC consultant engineers, and students. Welcome back to VK Jain Sir ki MEP classes. In this particular module, we are going to learn about evaporative type of cooling, which provides a very cheap alternative for comfort air conditioning. Friends, evaporative cooling is the ideal solution for reducing temperature in large indoor areas. It provides significant cooling at a fraction of the price of traditional air conditioning, typically 70% less. This makes cooling large commercial and industrial premises a viable option. One or more evaporative coolers are installed either on the ground directly outside the building or on the wall or roof. The unit cools air by drawing it in through continually weighted pads. This chilled air is then pumped into and distributed around a building via ductwork. Friends, in evaporative cooling, we have a water tank in which water is stored and that water is recirculated via pump onto a cooling pad. This cooling pad is the outside air is made to flow across this cooling pad, and there is a fan which circulates the cool air into a space where it is supposed to be cooled. This system has got a fan. So let me summarize. We have got a water tank system through which the water is pumped and sprayed vertically downward to keep a cooling pad wet, over which outside area outside air is made to flow, and that through an exhaust fan or fan is supplied in the room to be cooled. Friends, the evaporative type cooling applies adiabatic cooling with humidification, otherwise known as evaporative cooling. Cooling of the air with the help of water available at room temperature is accomplished by addition of water vapor in the air. When this water is circulated again and again adiabatically, that is without addition of external heater to water, this process is called evaporative cooling. An adiabatic process is a type of thermodynamic process that occurs without transferring heat between the thermodynamic system and its environment. Unlike an isothermal process, an adiabatic process transfers energy to the surrounding only as work and or mass flow. Air is passed horizontally through a vertical downward water spray of fresh water coming from down from nozzles of air washers. Water is recirculated by pumps which suck water from a drain pit and pump it through nozzles or air washer bank. Due to continuous circulation of water, air washer will soon attain a temperature equal to wet bulb temperature of air entering the air washer. Temperature of the air washer will remain now constant till the outside air condition remains constant. Friends, we shall try to understand the adiabatic cooling process of evaporative cooler. In this system, no refrigerant is required and cooling occurs by mechanical work done only. This is a very uh, this involves very less cost. Let us see through the psychrometric chart. Uh, Normally in summer hot days, say April, May, June, July in NCR region, where the rains starts only in July. So in these 4 months, the outside temperature may, may be something like 41 degrees to 43 or even 45. And this point T1, the point A represents that that during noon hours at about 4:30 or 4 o'clock, the temperature is near 41 to 45, and relative humidity may be very less, around 24 or 25%. So this represents point A represents that condition, and from this adiabatic cooling process of evaporative cooling, this temperature is brought down to something like the point B through constant circulation of water over a wetted pad. So the temperature comes down to B, but actually practically it is the C point. That means 26 degrees Celsius, which is comfortably um, cool for human subjects in India and particularly in NCR region. We'll try to understand this evaporative process through this sketch, in which there is a water tank below, and we have a bank of spray nozzles provided at the top, and we have a fan, normally exhaust fan, which circulates the air and the water is dripping. This water is dripping from top to bottom, and there may be some media also to carry the water uniformly throughout the surface. So we provide eliminator and filter also. Filter for dust particles in air, and eliminator so that the water does not enter outside from inside to outside. The eliminator is provided in both the sides, and the cold and hot water which gets accumulated is carried forward to top of the system, that cooler body. Friends, this is already covered by us in previous slide. Once again, the adiabatic cooling in a large air washer system. This figure illustrates the arrangement of nozzles and uh, the pump and circulation of water. In HVAC, In HVAC, an air washer is a type of equipment used for air cooling, humidifying, dehumidifying, and cleaning. It works by passing air through a spray of water, which helps in cooling air, controlling humidity, and dehumidifying in summer with chill water, removing dust and pollutants. Air scrubbing action. Main component are casing. This is the casing. This may be a room with insulated panels. Then spray nozzle in number of rows. Water distribution system. Recirculating water tank at the bottom and pump. This is the pump. So this is all one in what is known as air washer, which is a big form of room cooler. Normally we employ in our houses during the month of uh, April April, June, July, 3 months. Friends, there are three types of evaporative cooling systems. First one, direct evaporative air cooler called desert or swamp room cooler. Second, indirect evaporative air coolers. Third is mounted draft air coolers. Friends, the evaporative system may be of direct and indirect type. First, let us take direct evaporative cooling, also known as direct adiabatic cooling or wet valve cooling or desert cooler or swamp cooler. It is called direct as there is direct contact between the water and air stream. During the direct evaporative cooling process, water is evaporated directly into the air stream that needs to be cooled down. This type of evaporative cooling is most used from worldwide, worldwide, especially in dry regions. Disadvantage of direct evaporative cooling is that when it is used for space cooling, it adds a lot of moisture to the air, causing indoor climate to feel damp and clammy. Another disadvantage is that direct cooling is less efficient in regions where outside relative humidity is higher. This is because the system cannot evaporate water as efficiently when the air is already saturated. Friends, we have already learnt about direct air cooling. Now we shall learn on indirect evaporative cooling system. And indirect evaporative cooling, hot air and water travel in different channels and don't come directly in contact with each other. Hence the name indirect evaporative cooling. The warm air and another movement is why through this is the primary air stream which travels through indirect portion and cool air is supplied, and this is primary air stream. There is secondary air stream which travels vertically over the same system which is adjusted from top. This diagram shows indirect direct evaporative two-stage cooling system in which the warm air, which is primary, comes in the vessel and it supplies cool air, and once again direct cool air is supplied to the room. This is through primary, and there is secondary air stream which goes vertical and gets adjusted. With the help of evaporative and cooling represented on psychometric chart, the outside design condition is 42 with 23 RH. So this is the point 42 here and 23 point. This is 20, this is 10. So this point represents uh, the outside design condition, and by adiabatic cooling the curve by repeated adiabatic cooling we come to this point which represents outside design condition, and it may be something like 25.4 to 26 as already shown in some previous example. So this is the point, and this is the adiabatic cooling process. We can see through calculation the temperature drop achievable by adiabatic cooling is equal to dry wall minus wet wall multiplied by efficiency of the media. Example 42 degree and wet wall that time is 23.5 degree multiplied by 0.9, it gives 16.65 degrees by which the temperature can be brought down. Friends, this shows adiabatic cooling on psychometric chart in two stages. First, uh, cooling from outside temperature to some intermediate point, and then adiabatic cooling to the final point. Friend, this shows a two-stage or indirect or direct evaporative cooling system. Second type. In this, primary air is like this and secondary air goes like this. The primary air travels through a wet heat exchanger, water soaked cooling pad, and through exhaust fan this is taken out. Whereas the secondary air goes like this vertically and through heat exchanger point material, that is the wet pad of the cooling of the system, and a secondary fan takes the wet air out, wet heat out of the system. Friends, according to American Society of Heating and Refrigeration Engineers, ASRE, advanced two-stage evaporative cooling can use 60 to 75% less electricity than conventional refrigerant-based AC system. While this makes evaporative cooling a very attractive option in terms of energy efficiency, its most Important to note that these systems are best suited to dry, hot climatic found in America Southwest and composite climate of India, mostly in North India portion. Thanks for peacefully watching my presentation of this particular module. Thanks once again.